Hello and welcome to the Computer Vision Festival, hosted by the AI Accelerator Institute, a global community of over 400,000 AI leaders and practitioners, all striving towards one shared goal: inspiring the next generation of machine intelligence. With expert presentations on the festival agenda covering everything from space exploration on Mars to self-supervised learning, you're in for a treat. If you have any questions for our speakers or want to connect with them further, then ask away in the comments sections of the video and hear them answered at the end of each session in our live Q&As. If throughout the day you're loving the content, then be sure to check out the AI membership plans, where you can get access to exclusive content in the form of interviews, reports and articles. Access all areas passes to all past and future events. You can also join our Slack community, which is home to more than 2,500 fellow AI, machine learning and computer vision professionals, and is full of dynamic conversations and contributions. So if you're not already a member, come and join us today. Sign up using the link on the AI Accelerator Institute website. I want to say a massive thank you to all of our sponsors and partners for helping us to bring the festival to your screens today. Our amazing speakers for contributing some awesome content, and to you, our attendees, for joining us today. That's it from us, so go ahead, sit back, relax, and enjoy the festival. Okay, all right then. So if we just leave it a few seconds for everyone to come into the room, and we can just see that they're coming in now, and then we'll get your session underway, Gary. So it looks like pretty much everyone is in by now. Okay, awesome. So welcome everyone back to the Computer Vision Festival. Hope you're having a good day so far. I know we kind of overloaded you with some heavy content so far, but stick with us. There's some great presentations left. Really excited about this one. Gary Brown is, how can I put this, an old friend of AI. He's been helping out our community since 2019, putting together some awesome presentation and never fails to deliver. So the presentation today is on revolutionizing vision and edge AI applications with CPUs. And on that note, Gary, I'll leave it over to you.
Great. Thank you, Jordan, for that introduction. I'm really excited to be here at this online conference presenting live, and we're doing great, and I hope you're all doing great as well, staying safe. And it's really interesting what our pandemic has done for the computer vision industry. We'll talk a little bit about that. It's actually had some positive effects and people deploying technology faster, which is really very interesting to see. So as Jordan said, I work at Intel. I'm a director of marketing in our IoT group. And what we're going to talk about today is how AI, and in particular computer vision at the edge, is revolutionizing applications in many different markets. I'm going to talk about how intelligence at the edge is really giving not only silicon providers like us, but also equipment makers, distributors, SIs, software vendors. Everyone in the ecosystem is really benefiting from deploying at the edge. And so there's been a growing opportunity. The opportunity is there, as we all know from this conference and from the talks this morning, in a variety of different markets, from aerospace, we heard about that, to robotics, in manufacturing and industrial automation, healthcare and medical equipment, retail, in particular visual retail, shopper tracking, and we'll talk a little bit about that as well, and public safety and security, which is actually one of the largest areas for deploying computer vision, especially at the edge. So we all know that the edge is growing, it's mainstream. It probably doesn't need to be stated, but Gartner says it the best, entering the mainstream as we're taking and extending the cloud to on-premise. What I like about this quote is that we're not talking about moving out of the cloud and to on-premise at the edge. We're talking about extending, because I think there's a continuum from the cloud to the edge where companies are realizing that AI shouldn't be in one place or the other, but we should be using AI both in the cloud and at the edge in very particular ways to get the best benefits. If we look at the market opportunity, it's been growing large, and over the next several years, we'll continue to see amazing growth in retail and consumer applications, smart city, traffic kinds of applications, and infrastructure and others. So everybody agrees the edge is growing fast, but it isn't without its challenges. And that's why I was really excited when Jordan invited me to speak here and to come to present this, because the way we look at the edge and the cloud is like this diagram here. So this is kind of how we look at system architectures. We see the smart endpoints on the left, cameras, traditional IP cameras. They can even be smart cameras connected up to equipment at the on-premise edge, whether it be an AI appliance, which we'll talk more about, or a network video recorder, or the gateway there, and then going into the cloud where we have storage servers and network attached storage. So the challenge, of course, is you need enough performance, but you also need low cost and low power when deploying at the edge. And especially if you look toward the left, deploying intelligence in cameras, or deploying more and more intelligence across many different cameras in a network appliance or network video recorder, you're looking at the cost per channel, but also maintaining enough performance to give you the analytics that you need across all of your video channels. So there's a lot of challenge in terms of deploying at low power, at high performance, the right algorithms that give you the right real world accuracy, because we know that the real world is a lot different than benchmarking, and does what you need for the edge. So let's take a look at some usage models and some particular configurations, which from Intel's point of view, there's been a trend in the growth of these kinds of configurations. First, the edge converged server. So this kind of large on-premise server, which almost looks as large as a data center kind of server, but would appear on premise, combines storage and analytics, and is able to kind of do everything in one box. So an all-in-one kind of server. Now, if you already have a network video recorder that stores the video coming from cameras throughout, let's say, a retail store, you don't necessarily need to upgrade that equipment. You could take a look at something like an AI box or an AI appliance here on the right, where you're really just taking in many video channels, doing analytics on those channels, and you can add it into an existing infrastructure for the lowest cost upgrade to add intelligence into your edge network. So these are the kinds of configurations that we're seeing are growing in popularity as companies, businesses of all kinds, are adopting AI at the edge for computer vision applications. And we have an ecosystem of over 1,000 partners that are deploying various kinds of technologies, whether they're ODMs making equipment, or OEMs, or software companies. You see a variety of companies listed here that are doing really innovative kinds of edge deployments of analytics, video analytics. So what I'd like to point out is that there is a pretty large variety of the kinds of companies that it takes to deploy the technology. I'll share with you an in-depth view of what our channel looks like a little bit later, but let's stick to the technology for now, and go a little bit more in depth into what these AI appliances and converged servers look like. So the AI appliance that we're promoting currently is based on our recent announcement of the 11th gen Intel Core processor, codenamed Tiger Lake. Now, the way that this processor, which you wouldn't expect, provides very good AI performance is that it doesn't use an external accelerator chip as a companion or co-processor. It actually has built-in AI acceleration in the architecture. So it has an embedded Xe graphics core, an embedded GPU, and runs our OpenVINO software toolkit so that you can compile from any kinds of AI framework. And our ecosystem of partners are using these boxes to be able to port software and to be able to deploy at the edge with a minimal amount of equipment upgrade. And for me, I've looked over the last few years at so many different companies wanting to get the best AI performance, but it's not always about the performance by itself. It's also about the cost per channel, And there are different ways that different companies and businesses will measure their cost, but either essentially the total cost of ownership of the overall equipment or the cost per video channel is typically what we're seeing, as well as achieving low power. So you need to meet a minimum spec for the accuracy in your computer vision algorithms, but you also need to be able to deploy at low power at the same time, and also keeping your equipment costs down. Now, some companies are deciding to deploy AI and computer vision brand new and using this kind of edge converged server. We recently announced a new generation of Xeon processor, which is our highest performance data center processor. But in the IoT group, we're actually adjusting the specifications of the Xeon processor to be able to have extended life, extended temperature range, and various kinds of fortifications for IoT deployments. And so building a server around this third generation Xeon scalable processor, which was codenamed Ice Lake, will enable being able to do a lot of video channels of analytics plus storage in the same box. So these are the kinds of trends that we're seeing, and it's amazing to see how in many industries there's an insatiable appetite for computer vision performance. Now, the challenges are only starting when you talk about power, performance, and cost. I think one of the biggest sort of not yet fully talked about system requirements is the fact that AI and computer vision aren't really standalone applications. If you look at the way people are deploying computer vision and AI, it usually needs to be done in a very secure way. So you need cybersecurity. And then you might add video codecs. You might have to do many channels of video decoding in addition to your analytics. You'll need pre and post processing. And we're seeing applications making use of the latest networking and communication standards like 5G. So an AI application is not always AI by itself. You definitely are combining a lot of functions together. And thus, it helps to have general purpose processors that have built-in AI acceleration, because sometimes you need to use embedded CPUs to run different kinds of pre and post processing, or to be able to deploy with video codecs that are embedded in the same processor. So we're looking kind of at a higher level at all of the different specifications and functional requirements in a system architecture. And what we find is the AI is at the center, but there are many, many more features that you have to add in. So taking a look at all of the different requirements listed up here, you have analytics, of course. In a typical server, we'll see anywhere from as low as 2 to over 32 channels of video decoding required with analytics on each of those channels. In some cases, multiple CV algorithms running on each of those channels. So you have, like the next line shows, 1080p H.264 decode on many channels. You might require storage. You might require security as well. And, so there are many different requirements put together. And then moving along here, we're going to talk about what actual companies are deploying. I love to showcase recent examples of deployments that I think are very interesting because they converge AI and edge CV with other applications. So despite the challenges in edge deployments, we're seeing businesses are really able to deploy, and using Intel CPUs, they're able to get AI acceleration plus all the other features required. So one example that I really want to point out, a few months ago that was announced, of our partnership with Core AVI, a company based in Florida that does avionics systems. And this is for safety critical applications. And so using Intel's Core processor, they're able to get, with the embedded GPU, up to four 8K displays of display processing using the embedded GPU on the Core 11th Gen Core processor, as well as CV and AI applications that they can deploy at the edge in aircraft. So the point is that in a safety critical application, the processing isn't just the AI by itself, but you have other kinds of safety critical features as well as display processing that you have to do. So you can look for that announcement to read more details about what Core AVI is doing. It's really exciting to see this kind of deployment in avionics of edge AI. And now moving on to to retail stores. I really look to the evolution and revolution that's going on in retail, not just with people counting, but very intriguing applications. And so this partner of ours called MELD-CX has been working with a company, Pro-Life Foods, on deploying computer vision in retail POS systems. What's exciting about this is that from what I've been reading, I'm not the retail expert, and on Thursday morning, we're going to have a panel with some of the retail experts. I hope you can join us there. But there's a huge issue with product loss and accuracy, and being able to detect what product a customer is buying and to do it quickly and efficiently, and to be able to deploy this with sufficient performance and accuracy and low cost must be a huge challenge for retail stores. But what MELD-CX has done with their software is offer this kind of smart scale solution that detects what foods the customer is buying and is able to use computer vision quite accurately at the checkout counter. Very impressive stuff. And I think we're going to see more and more deployments in retail moving forward, kind of like this. Now getting back to the Xeon processor, which I mentioned was our data center grade high-end processor, codenamed Ice Lake. This processor is fairly high performance. Compared to the last generation, codenamed Cascade Lake, it offers 46% average performance improvement. And in AI applications like image classification, 56% performance improvement. And so what we've seen so far is this company, Claro 360 in South America, which has hundreds of thousands of cameras that they need to run analytics to be able to allow consumers to come back into shopping centers safely and to either have social distancing and to do various kinds of computer vision. But to deploy it in a shopping center, in many different shopping centers with many cameras, means that you need high performance servers that have enough AI and computer vision to run analytics across all of your video channels. So this is just one example of a company that we're working with, Claro 360, and you can look more to the announcement back in April when we launched this third generation Xeon SP processor. Really exciting stuff. And so underneath the hood, we're going to take a little bit of a dive to talk about the roadmap at Intel and how our Edge AI compute processors can unlock the secrets of CV deployment. So first, taking a step to look from the bottom up, we have processors from general purpose CPUs that offer AI acceleration, like I talked about, to integrated GPUs on our new core processor, and FPGA and vision processors as well that are discrete accelerators. On top of that, we offer an OpenVINO toolkit, which is powered by one API, and I'll explain that in a moment. If you want to take an algorithm and you want to optimize for a particular processor for a particular application, sometimes portability can be a real problem because you have to re-optimize the application to run efficiently if you're mapping to a different processor. But what we've been able to do across the whole product line at Intel is offer this tool suite to be able to port the application once and then optimize again if you want to move to a different processor. So let's say you're optimizing to run on your notebook computer and you're running an experiment to run AI algorithms on your notebook PC, but now you want to deploy on the 11th gen core processor, Tiger Lake, in some kind of edge computing high performance AI application. Then you can do that with OpenVINO just by retargeting to the new processor. So having a tool suite that enables you portability and scalability of your applications is very helpful. And if we take a closer look now at our hardware and software and development tools, what we're trying to show is a right sizing of the tools and ingredients to be able to meet a very different scalable kinds of needs in terms of performance, power, and cost. So I can't predict for your particular application what performance, power, and cost you need to target. But if it's if it's some particular set of requirements, you'd like to be able to use the processor that meets your needs and the software that's able to run at the performance and accuracy required, but at the lowest possible cost and power. And so that's what we've been able to do at Intel with our processors from the Xeon and the Core and the Atom and the discrete accelerators. We also have development kits. We have partners that are engaged in developing their own vertical market development systems and application software, and software tools like OpenVino that I talked about, and other kinds of free tools like the DevCloud for the Edge, which is a sandbox online that you can use to go test out new kinds of Intel hardware, as well as Edge Software Hub that gives you application-specific or vertical market-specific applications that you can test out and run and prototype. So with that, I will move on to the more important view where the Intel ingredients that I just showed you are here on the left, but there is this really big heroic journey to really get real life computer vision applications deployed in a consumer setting or in a professional setting. It takes the distributors, it takes the ODMs and OEMs and system makers to integrate the software and develop the software correctly. And then it takes solution providers that are developing the kits that solution aggregators and system integrators can take to their clients, who are finally the end users. So the end users, who probably don't care what hardware and software is under the hood, they just want to meet the specs. They just want to be using the deluge of vision data that they can use to get improved value in their business. But there's a whole channel of these partners that can help deploy the applications. And I think it's brilliant that we've been able to work across such a large ecosystem of these kinds of partners. So if you're considering working with Intel and you'd like to become a partner, we have an Intel Partner Alliance. I'll just quickly mention this, which has various benefits. There's definitely some love that we give to our partners to be able to take solutions to the market in a variety of vertical markets. So we look forward to partnering with some of you. And overall, we see Intel as kind of the foundation of this triangle, the foundation of developing silicon and tools that then can get into the hands of our partners, who then create applications and market-specific solutions, so that whether it's manufacturing environment or retail environments or smart cities, we can see these applications grow and grow. So if you'd want more information about where to find these kinds of technologies, you can either reach me. I'm going to be hanging out online at these talks. We can chat more, or you can go to our website and look at intel.com/vision products to see a variety of the software and hardware tools that we and our partners provide, as well as the intel.com IoT page, which tells you a little bit more about all the other IoT fortified specifications of our processors that we sell. So with that, I really appreciate all of you here for the talk today, completely live, and really exciting that I didn't have to pre-record this. And we'll look at the disclaimers a little bit, and I'll go to some of the questions. So now let me turn my attention to some of the questions here in the question. Feel free to, will there be a link to this recording? I believe that Jordan and the team will have a link to the recording. I don't see any questions yet, but feel free to put some up. We have about 5 more minutes. Jordan, it's interesting because a lot of times people will ask me, like, how do you compare with your competitors? How do you compare with discrete GPUs? How do you compare with other alternative silicon providers? And I think one of that question usually always comes up. And the way I usually respond to this is to say, it's not just about the silicon and what it can do. Of course, if you look at the whole system's requirements, you end up with some kind of performance that you need, but you also end up with cost. And typically it's in terms of, how many inferences per second per channel you need across all the video channels, and then the cost per channel that you're actually spending. So if you have to upgrade your equipment with a lot of expensive hardware in order to get the performance you need, it's not a matter of just the performance. It's usually a matter of the cost that that you're spending at the same time. So what we see with real businesses that are trying to deploy CV in retail or in industrial settings, the cost is a major, major factor. And so, where companies are trying to upgrade to more intelligent solutions, usually Intel processors are there. And if those Intel processors, which you wouldn't expect being high performance in AI, can actually do AI, like our Ice Lake and like our 11th gen core processor, which gets pretty decent AI performance, you should test out those processors, because they're not just your grandfather's processors. They are up to speed doing deep learning boost technology, which is our AI accelerator that's built into our processors. So I would say that looking at how little money you need to spend to be able to get the computer vision that you need is the kind of the mentality that we see among customers that are deploying today. And so it's not just about how many tops are you versus the tops of your competitor. So, if you're doing a simple benchmark, then sure, you want to compare tops, you want to compare inferences per second, that's fine. But when it comes to real world deployments, it's a lot more sophisticated in terms of cost and power and other kinds of things.
Understood. Totally understood. So there's a few questions coming in now, Gary. There's
yes.
quite a few people tuned in. No one be shy. All questions are welcome. So we'll start with the first one from Josip. So, among bringing the technology on edge devices, is Intel developing computer vision models that tend to work better on edge devices rather than reusing usual models developed on GPUs?
That's a really good question. So when you're developing a model, if you go back to the beginning of the data scientists who are culling their data and creating the models to do what they need to do, it then needs to be optimized for the hardware you're trying to run on. And if you tweak and tune and deploy a model on GPUs, the question is, do we have better computer vision models that work better on other edge devices? And I would say yes. I would say our OpenVINO toolkit has many examples in our model zoo of models that run just fine. I would also argue that if you have a TensorFlow or if you have an existing model, it's usually hardware agnostic. And so you could start back with your model handed over to you from the data scientists and probably get just as good results if you look at the tools and what knobs and buttons you're able to use in the tools to optimize. And for example, in our OpenVINO toolkit, we have a lot of different ways to optimize the model and do pruning and all of those standard things. But we also do a lot of specific features depending on the optimization for the exact hardware yourself. So when you're deploying on a VPU versus one of our CPUs or the embedded GPU on the Intel Core processor, then there's certain architectural optimizations that the tool suite will take care of. So, but you can see examples of that, like I said, in the model zoo in our OpenVINO toolkit. So check out the OpenVINO toolkit and you'll get more information on how to improve your computer vision model's performance.
Cool. Go and check it out, Josip. So what are the Intel solutions on VPU?
Okay, so this sounds like a very high-level question about VPU. So as a part of our silicon offering, we have the Movidius VPU products and accelerator cards that are built by partner companies that can accelerate based on the VPU. So depending on the performance, cost, and power requirement, like I said before, you might choose an accelerator card based on our VPU. You might choose an accelerator, that's a part of our CPU offering. So when you ask what are the Intel solutions are typically the silicon and the software tools, some development kits. You could also look to our partners. If you go to the handouts, I actually provided the conference with a handout that you should download that looks at a lot of the partner solutions. So those are the solutions you should be looking at, the ones from our partner ecosystem. Those are the ones that are tailored to various vertical market solutions. Those are the ones that are tailored to differing power and cost and performance. So I would suggest, Markadan, if you want to go download that handout that's in the handouts area. Very good question. Thank you very much.
Cool. Yeah, thank you very much, Markadan. I'm not going to even attempt to pronounce this second name, but I'll read out the question. Can these silicons replace CPU plus GPU set up on edge? What are the trade-offs with regards to price versus performance?
Okay, very interesting question. So I talked about Xeon processors, core processors, and embedded GPU that's in our new 11th gen core processor. And can the silicon replace CPU plus GPU? So if you have a solution today that has discrete components for the CPU separately from a GPU, then for certain you should be evaluating our new processors that have embedded GPU. And you should look at a variety of different hardware that could meet your needs. Price versus performance. Also, there's power. I can't tell you what specific trade-offs you're going to see, but if you use some standard benchmarks, that's one thing. But if you use the software that you intend on deploying commercially to evaluate the processors that we provide against alternatives, then you can check out the trade-offs on your own. And I think most companies should do very careful evaluations. Some companies will do very quick evaluations on benchmarks, but I suggest using the software you plan to deploy, put it into OpenVINO, check out our processors that integrate the GPU, like the 11th gen core processor. That's the one you should be looking at, and then you can measure your trade-offs that you see. So good luck with that. And Abhijit, I appreciate that question. Thank you so much.
Nice one. So another kind of like high-level question about self-driving cars here. Panir Salav wants to know how Intel tools are used.
Yeah, we have a whole division working on autonomous cars. So I'm smiling because I'm not the person to talk about that. In the IoT group, we're deploying technology at the edge. But when we talk about the edge, we're talking about the edge, not including autonomous driving. But the autonomous driving team, if you look on our website or you want to get in touch, we can put you in touch with them. They'd be happy to tell you more about Intel Silicon and the amazing things we're doing with autonomous cars. That's the Mobileye division. So you can look up Mobileye, Mobileye.
Exactly.
We're doing amazing stuff. It's just that I'm not the person to talk about it. But yeah, cars are a whole nother area that's really, really exciting in what's going on with computer vision. And the amount of computer vision deployed in cars is just mind-boggling. So very, very interesting.
And then from Juan, how do you see the FPGA development and implementation with IA?
That's an interesting question. FPGAs have traditionally been used. It's programmable hardware, so you write, the hardware, or you get various kinds of instantiations, and it gives you a different kind of performance cost curve, which is very, very useful. Not just in prototyping. It used to be only used for prototyping back in the beginning of my career. I remember making FPGA prototype boards for demonstrations. But now people are deploying FPGAs in real applications. Implementation with IA. So by IA, Intel architecture, we're talking about the Xeon Core and Atom CPUs. So people are using FPGAs as co-processors where needed to get a certain performance, price, power curve. If you look at those three dimensions, where you are in terms of the application requirements is different than everyone else. And so for some companies, you need an FPGA, and that's where we use FPGAs alongside our CPUs. Our CPUs always give you certain kinds of cybersecurity, performance, and AI acceleration, but the FPGA can also add the discrete accelerator kind of component as well. And if you want to contact me offline, feel free. I'll tell you more about what we're doing with FPGAs.
Cool. Thank you very much, Gary. Another question from Abhijit. I don't know if you just want to have a read over that, Gary, and see if you find the question in there.
Yeah, here it is. Examples with devices mostly speak about computer vision. Are the devices equally capable to run models that handle text or speech, let's say ISTMs or GNNs? Okay, so you're bringing up text or speech kinds of data. And those are also valid, and those are an area that we're moving into with our OpenVINO toolkit. What I'm focused on mostly is computer vision for visual kinds of applications. And so there are many kinds of use cases, for example, in traffic, where you want to have a camera that's not only looking at maybe car accidents that might be happening, but you also need audio data to be listening for broken glass, listening for car accidents, car crashes, those kinds of things. So combining the multimodal kinds of sensors from speech or audio alongside computer vision, I think has an incredible amount of value. And we're going to be seeing a lot of that. I can't say anything more specifically because my focus is computer vision, but a really good point. Thanks for bringing that up, Abhijit.
Thanks, Abhijit. So on to Pankaj. What about networked capabilities of these boxes, connecting spatially nearly sensors together for distributed connected computing?
I think we're talking about nearby sensors, and you need to have connected computing where the sensors are nearby. We have a network products group, NPG, that our IoT group works closely with, that combines various solutions, for example, 5G networking with AI. And we have various deployments of proof of concept systems and demos. We have customers using these kinds of networking, advanced networking features like 5G. I don't understand specifically what you're asking, but I think what I'm seeing in terms of a trend is since last year, there's more of a need for high performance networking. And if you look at our processors like the new third generation Xeon scalable processor, codenamed Ice Lake, we support high performance networking on those processors. So definitely an interesting aspect is the networking requirements. And something to be said is the whole reason why deploying close spatially nearby sensors is to avoid the over use of the network and avoid power in the network, to be able to lower your power because you're not having to send video into the network. So when you have a server on premise in a retail store that handles 30 or 40 or 60 channels of video, you're not having to send the video into the network. You can send the metadata that you extract from the video. And that's the whole purpose of computer vision, really, is to be able to really alleviate the load on the network, alleviate the load in the cloud by doing a lot of your edge analytics close to where the sensors are. Really good point. Thank you.
Okay, cool. So it looks like we possibly are coming to the end now, Gary, just in time as well. But yeah, just wanted to say another huge thank you. You always deliver great value to these festivals and these conferences. So we'll have you back anytime that you like. But yeah, it's a pleasure to have you present again, and thank you once again to the audience. Some great questions. Thanks for participating. I'm going to put the link to the next session in the chat box now, and we'll move over. But once again, a big thank you, Gary.
Thank you, Jordan. Thanks, everyone. Have a great day at the conference.
Take care. See you later. Bye-bye.